So we have the next topic, which is the definite integral. So we have now the integral here. After you make an integral, will have no constant. Okay? It will have no longer the constant of integration, but and with limits, and then the final answer will be a constant. Okay. So the model here is this one. Okay. So you'll have here the integral of a to b f of x dx is equal to capital F of fx. So that is limits from a to b. And then it will be equal to the f of b minus f of a. So what basically you will do here is just substitute the value of b and then minus it to the minus it, then substitute to the value of a. So a here is the lower limit and b is the upper limit. So note here that definite integral can be solved easily by ES. Can actually do that. What I mean by ES here is by calculator. If you have a calculator, all you have to do is plug in the equation on the calcu and the calcu can solve it all by itself. So we have here some theorems. So number 1 theorem is already the same with this one. For number 2, it is equal to negative integral of a to b f of x dx. It will be equal to integral of b to a. You can actually interchange the positions of the limits if you have a negative here, and then you can just remove the negative. Okay. And then for number 3, we have integral of a to b f of x dx equal to integral of a to c f of x dx plus integral of c to b f of x dx. So this is actually quite useful in some of the some questions. For number 4, this is actually a very useful one. So this is integral of negative a to a f of x dx. So for example, the limits are from negative 1 to 1 or negative 2 to 2, negative 3 to 3. Okay? So anything, something like that. It will be equal to 2 integral of 0 to a. So as you can see, the negative a, the lower limit became a, provided that you will have here 2 on the outside, f of x dx. Provided again that if the function is an even function. And then if the function is an odd function, then it will just become equal to 0. Okay? So note that even function is, you can say that a function is even if f of negative x is just equal to f of x. Okay? So they are basically just equal. And then we have the second one. The next one is the Wallis formula. So if the given is something like this, exactly like this, that is integral of 0 to pi over 2 sine raised to m of mx cosine mx. Okay? Or you can also read it as sine x raised to m. This actually must be mn. Okay? The second one must be n. Let me just so this one must be n. This must be n. Okay, so this is just equal to m minus 1 times n minus 3 times n minus 5 up to the result will be 1 or 2. Okay, so that is when you will stop. The next one is n minus 1, n minus 3, n minus 5 until it became 1 or 2. And then for the denominator, you'll have the sum of their powers m plus n times m plus n minus 2, m plus n minus 4, m plus n minus 6 up until it became 1 or 2. Okay, and then you have to multiply it by alpha. Okay, the value of alpha will be pi over 2 if and provided m and n are both even. So the for example, m and n are 2 and 6 or 8 and 10 and or 4 and 8 or anything like that. But as long as they are both even, the alpha will be pi over 2. So you have to multiply all of these into pi over 2. And then if they are not both even, let's say they are both odd or one of them is odd or one of them is only even, and then our alpha will just be equal to 1. Okay? So let's move on to a problem. Okay, so solving the first problem, we'll have here the evaluate the integral of dx over square root of x from x equal to 0 to x equal to 4. So writing that, you'll have here integral of square root of x, right, dx. So we have here limits from 0 to 4. Okay, so what I can do here is I can make it like this. So 0 to 4 and then bringing square root of x is just also equal to x raised to 1/2. And then if I will bring it up, you have to change the sign of the power or the exponent. So you'll have your x raised to negative 1/2 dx. Okay, and then applying the power rule, this is just a power rule, so it will become negative 1/2 plus 1, right? You have to add the 1, so you have here 1/2 all over 1/2. Okay, and then the limits of this one will be 0 to 4. And then um, simplifying this one, you'll just have here 2 square root of x. Okay, limits from 0 to 4, and then equal to you can actually bring 2 out, okay, and then 2 times square root of substitute the upper limit first, and then minus substitute the lower limit. Okay, so this is just, of course, this will just become 0, and then this is 2, so 2 times 2, so the answer is just 4, and this will be your final answer. So let's go to the next one. Okay, so we have here the next one. Evaluate the integral of sine x raised to 6 and then cosine x dx. Okay, and then this is from 0 to pi over 2. So as you can see, this is exactly the same or the model of what is formula. So going back to that, so this one. Okay. Okay, so as you can see, the integral of this one is just the numerator will be 6, right? So 6 minus 1 first, and then 6 minus 3, so that's already 3, and then 6 minus 5. Okay, so this will be for the power of sine. Next one is for the power of the cosine, which is 4. So 4 minus 1 times 4 minus 3, and then that will become 1. So you have to stop there. Okay, so that's just make sure that it won't be a negative. And then for the denominator, you have to add both of the powers. So that will be 6 plus 4, okay, times 6 plus 4 minus 2, right? Here, minus 2, and then minus 4, and then minus 6, until it become 1 or 2. Minus 2, okay? Mhm. Minus 2, and then 6 plus 4 minus 4. So this is quite long, and then this is already 10, 8, and then this is 6, right? And then you'll have here 4 up to 2. Okay? So 1, okay? But as you can see that the powers are 6 and 4, so they are both even. Therefore, you have to, let me just write this one. You have to multiply this by pi over 2, because they are both even. Okay, so getting the product of that, you'll have let me simplify it first. So simplifying that, you'll have 5 times 3 times 1, so this will be for the power of sine, and the next one will have 4 minus 1, so that's 3 times 1. Okay, for the denominator, you'll have 10, and then minus 2, so 8, 6, 4, and then 2, and then multiply it by pi over 2. That's it. And then the answer for this one is, that's the answer, 0.0184. Okay, so that will be 0.0184. You can also try it on your calculus to double check my answer. Okay, so let's go to the next number. Okay, So let's go for the next number, which is number 3. So we have here evaluate the integral of, so we have the integral of x plus x cubed plus x raised to 5, and then plus x raised to up to x raised to 99, okay, dx. So this is from negative 1 to 1. Okay. So we can just use here, as you can see, this is quite long if you will do it manually. So that's x plus x cubed plus x raised to 5, etc. So this is an add function actually. So if that is an add function, and then as you can see the limits are negative 1 to 1, you can actually um, apply the fourth theorem. Okay, so for the fourth theorem, you have here this one. Okay, so this one. So using the fourth theorem is integral of negative a to a, which is negative 1 to 1, f of x dx is equal to 2 integral of 0 to a, provided if that is an even function. If it's an odd function, that will be equal to 0. Okay, so as you can see, this is an odd function. So if that is an odd function, therefore this is really easy. So the value of this one is just 0. That will be your answer. Okay, let's go to number 4. So for number 4, we have the integral of 2 dx. So you have here 2 over x cubed, okay, dx. Limits from 2 up to infinity. Okay, up to infinity. Infinity. So taking the integral of that, you can actually bring out 2 to outside, to the outside, because that is just a constant. So integral of 1 over x cubed, I can just bring it up, and then the exponent or the power will become negative. So negative 3 dx. Okay, so taking the integral of that, you'll have 2 x raised to negative 2 over negative 2, right? And then limits from 2 up to infinity. Now let's try to simplify that. So you'll have here negative, right? So this will become negative 1 over x squared. Okay, so I already bring down that x raised to negative 2, so the power will now be positive. And then this still has a limit of 2 to negative to infinity. So substituting the value of infinity, so this is 1 over, okay, infinity squared minus, okay, negative 1 over 2 squared. Okay. And then equal, as you can see, this is negative 1 over infinity squared. As you can see, 1 over infinity, or 1 over a very large number, that will just approach into 0. Okay, so we can say that this part is already 0. Okay, so this is 0 minus minus, so this will become positive 1/4. Therefore the answer will just be 1/4. And there you go. Let's go to the next one.